We encourage active participation, so please feel free to ask questions using the chat box during the Q&A session after the talks. I will address the questions during the Q&A sessions following the talks. We are delighted to have Tuan Abdul Rashid Japar here today to enlighten us on the issue of landslide, which Malaysia always encountered. Let me read through some background of the speaker. Tuan Abdul Rashid Japar obtained Master of Science in Applied Geoscience, Engineering Geology from the University of Hong Kong in 2006, where he won Harcrow Prize as a mark of distinction and overall best students. And he obtains his Bachelor of Science with honors in geology from the National University of Malaysia, UKM, in 1992. He passed the Certificate for Safety and Health Officer course from National Institute for Occupational Safety and Health, Malaysia, in 2003. In 2015, he received Tokoh Alumni Swasta Award from the Geological Club of UKM. Abdul Rashid is a registered professional geologist with Board of Geologists Malaysia and a registered environmental specialist with Department of Environment Malaysia, DOE. He involved with construction industry, civil works, environmental, as well as groundwater projects. His major specialization is in engineering geology and geotechnical engineering, with occasionally involved in groundwater, hydrology, and geoenvironmental engineering. He has more than 30 years of experience working in construction, oil and gas, and mining or quarry industry. Abdul Rashid is the current president of the Institute of Geology Malaysia, IGM, president for Society for Engineering Geology and Rock Mechanics Malaysia, secretary of Malaysian Geoscience Consultants and Services Association Malaysia, and immediate past president of the Geologists Society of Malaysia. He was the youngest and among the first board members served the Board of Geologists Malaysia from 2015 to 2017, and now reappointed for 2020 to 2023. He is also a professional member of the Institution of Geospatial and Remote Sensing Malaysia, and as associate member of the Institution of Engineers Malaysia, IEM. Abdul Rashid is appointed as a adjunct professor for the Faculty of Earth Science, University of Malaysia, Kelantan, and adjunct lecturer, Department of Management and Humanities, University of Technology, Petronas, where he teaches professional practice and practical management for geoscientists. Okay, without further ado, let's welcome Tuan Abdul Rashid Japar to begin his presentation. Abdul Rashid, the floor is yours.
Yeah, thanks, Dr. Ng, for the kind introduction. I don't know whether the title expected and that I'm going to present, is it the same or not? Because
it's okay.
I do have that window. Okay. Hang on. Saya ini lari lah. Hang on, share. Just now, okay. I cannot see my. How come I only can see your face, Dr. Ng?
I think you try to maximize first your maximize.
Okay.
You see the icon there on the upper right hand side.
Okay. Yeah, just now I minimize it. Okay. You can see now my slide, Dr.
Yes.
Ng?
Yes, we can see that.
Okay. Thanks to UITM for inviting me to give this lecture. At first, I want to talk about the forensic investigation. That's what the earlier title given to me. And then later on, I found out that the title changed to understanding and mitigation measures. So anyway, I modified a bit so that I a bit general. Then if there's not detail into forensic investigation. But if you want to discuss about forensic investigation on soil slope, rock slope, natural slope, or man-made slope, that one maybe later you can discuss in other occasion. So the title today is landslide understanding and mitigating measures. I try to relate back landslide with local condition. Okay, Dr. Ng already give introduction on me, quite lengthy, so I skip that one. So, okay, this first slide is on most civil engineering projects are on the ground. That's why geotechnical engineering or engineering geology is very important. And for my talk today, I will focus on this part, landslide or slope, terrain instability, and so on. Okay. I involved with offshore geotechnical about 8 or 9 years when I worked in oil and gas. So if you're interested also maybe we can talk about it in other occasion. So this is important because every structure except aeroplane, except ship is all founded on the ground, right? So this is typical soil mechanic class in many civil engineering courses locally or abroad. This ground model taught by lecturer normally is just like a cake layer. You have sand, clay, gravel, etc. And then we have to calculate the stresses in the ground. Like here, this is the layer is very horizontal, nicely. Even though we have actually weathering profile here. Okay. So
Sorry, Cik Japa, sorry, the slide is not moving. The slide is not moving.
the slide is not moving.
Yeah. Can you turn on this presentation mode first?
Yeah, I already turned on. So I stop sharing now. Is it already at the second slide? Okay.
Okay, we share.
Okay, now you can see. This slide, the second slide, can you see the one or not?
No, still cannot see. Cik Masita, Dr. Masita, boleh nampak ke?
I couldn't see it also.
Tak nampak.
So I try to tadi okay kan? I try to keluar lah. I keluar and then open back. Sorry for the hiccup. Where is this? Okay. Now okay, Dr. Ng?
Okay, try turn on the presentation mode.
Okay, presentation mode on already. Is it okay?
No, we only see the file, but not the presentation mode.
Not the presentation mode.
Maksudnya bawah punya, kat bawah sekali ada satu presentation mode kan?
Ada, I dah klik dah. My screen I nampak presentation mode. Your screen tak nampak
Tak nampak. Saya rasa you tak apalah, you pakai yang ni, you scroll down sajalah. Slide by slide lah, macam tu.
Slide biasa
Macam biasa lah. Macam ni okey lah.
Okay. Okay, now I go to the next slide. Okay, nampak slide ni kan?
Yeah.
Okay, in most soil mechanic class, the ground model taught by lecturer always like a layer, as a cake. So what I'm trying to highlight here is too often an ideal model is confused with the real material. So the real okay, now we talk about, I'm not going to discuss about slope analysis because I believe you all already learned from your lecturer about the stability analysis. I just want to highlight here, okay, normally when we do analysis, we have a layer of soil profile, and then we do what do you call it, the secular analysis. Then you got all these things. But I want to highlight here that in Malaysia, because most of the slope is actually is in the weathered rock or soil derived from weathered rock. So unless you are dealing with grade 6 or residual soil, in homogeneous condition, yes, it behave like a circular failure. But if you once you deal with we call it saprolite in term of geology or geotechnical, in completely or highly weathered material, there's always sometime a plane that dictate the failure, like this slide, this photo at the bottom, where you can see it's not really a circular failure. There's a layer that sometimes dictate the failure plane or failure mode. So this is very important in residual or in a weathered material. So the next slide is if a normal ideal slope, this is basically in clay material or transport material in the temperate country is very straightforward, where you have a soil, then you have rock, and then you got infiltration of water, etc. But in our case, actual slope, we are more complicated than the normal soil slope in the book that normally written by people in the temperate country. We have uh, residual soil, we have a weathered material, and you have joint, all these joint. Sometimes the joint, even though is a feature in the rock, but it's in soil, it can preserve. So this joint become a plane of weaknesses. If we don't really look into this, then our analysis may not really accurate. So this model of geological model that in other part of the world, in developed country now, before we develop mathematical model or geotechnical model, we have to develop a geological model first to understand the ground before we simplify it, become then we can translate it into mathematical model. So the actual ground is very complicated. Like here, these rocks have been deformed due to tectonic or maybe some activity in the past. We're talking about millions of years activity, and then you have a different rock type, and then all this weathered material in between. We have all this structure. So it's very complicated. So it's very important to understand the ground before to visualize the ground before we translate it into a mathematical model, so that when we do analysis, we always have the real situation at the back of our head, so that all our assumption and our parameter that we input in our analysis is to reflect the true condition of the ground. This is another cross section. On the right here, the color one is from Hong Kong. This is granitic ground. It's typical granite. You cannot get like a layer. Normally, previously we put a grade 1 to grade 6 layer by layer, grade 6 on top, grade 1 at the bottom. But actually, it's not. You have a lot of at one point you cannot really segregate it layer by layer. You have to do it. You have to classify the mesh, whether it behave like a rock, where you use rock mechanic, or it behave like a soil. So then you can use soil mechanic for your analysis, or what criteria to use, more column criteria or hook ground criteria, thing like that. So this is from Derry and Pater, 1971. It's very long time ago. It's already do sketch. This study from Central America. So this is the on the right is for granitic material in years, which is similar from what we seen this one or previously. In the middle is for limestone or karstic or carbonate formation, and then this is for sedimentary rock or for meta sedimentary rock or metamorphic rock. So actually, the ground is more complicated than just a layer of a soil. So and then the next part is that we always forget is about geomorphology. Geomorphology is very important aspect of geology that we should understand, so that when we do analysis for any slope stability, so we know what we are dealing with. And like for example, this is postulate the 9 hypothetical division of a slope or landform. So if we understand that if we do construction in this area like a convex slope or fall face, there is a potential of natural landslide. So this is very active zone. So if we understand where we are, then much easier than we deal with the ground. And there's 2 books that I can propose, very good for geotechnical engineers who are interested with geomorphology or even for geology. Geomorphology for engineers or engineering geomorphology, both authored by Hooks and his friend. Peter Hooks already passed away 2 years ago. So very a good professor in engineering geology or engineering geomorphology in UK. And then now I go back to landslide. So we already understand the ground. I just touch a bit on the ground so that when we do landslide or slope analysis, don't take lightly that on the ground. So it's a lot more complicated than what we understand layer by layer. Sometimes in the Boholog also show just a simple layer, but actually it's not. We need to understand the ground. So based on Cruden, 1991, he is part of UNESCO Working Party on Landslide Inventory. A simple definition of landslide is the movement of mass of rock, earth or debris down a slope. So this is very simple. This is what is a landslide. And then of course we have a lot of other category that I will touch. And then this block diagram is very useful to understand the description of the landslide. You have a crown, main scarp, a crown crack, minor crack. So when we talk about landslide and when we discuss about, let's say, main body, we know what we are talking about. We are talking about crown. Crown is on the top of the landslide. So that everybody in the group that we are discussing know what we are talking about. That's why it's very important to have a accurate terms in terms of studying or understanding landslide. This classification of landslide. This is the latest one, update from by Hunger. Ulrich Hunger also passed away. I think last year. Ulrich Hunger is very famous in terms of debris flow or flow type landslide. Is based in Canada, passed away last year. Sergei Rilur, I think you all know, is from France and Picarelli from Italy. So they come up this classification updated from once in 1978. So recently they visited and then they introduced a better classification. So for example, landslide in Batangkali, I would say is a combination of rotational slide, is a clay seed rotational slide, and earth flow, because they got a two time of failure. First from the top fail, and then second where the first perimeter is burst due to there's a lot of subsurface water, so it's become earth flow, and then it can reach about 550 meter away. Normal landslide cannot reach to that distance, so it's earth flow. So it's important to understand this so that proper study or research can be done, and then at the end of the day, proper mitigation can be put on the failure area. And then this is the block diagram of the type of landslide. It's very useful. This is produced by British Geological Survey based on the classification by Hunger et al. And then next, to understand, in Malaysia, in tropical, where we have a weathered ground, there are common actually, but this is not really discussed in detail about natural subsurface drainage, or geologists call it soil pipe. It's not like the one soil pipe that normally civil engineer understand. So this is because of you have a weathered material, and then you got this a core stone within the material. So and then you got a relic structure like joint and whatnot. So the water actually can infiltrate through and then follow some parts, drainage part. So you can have a subsurface drainage naturally. So this is very important. This the top right is the photo where the real natural subsurface drainage occurred at the failure slope failure when they expose. And then what more important is we have to understand that sometimes the top layer is unsaturated ground or impermeable layer, but you have very high conductivity zone in between two unsaturated ground, where this is the failure, potential failure plane. This is what I believe happened in Batangkali, but we put it aside because the investigation is still going on, and then I'm a part of the team as well. And then another thing is natural weaknesses plane. This plane normally we do when we run stability analysis. We try to find the plane from the our circular uh, mode. But for this one, actually, in many of the weathered material, especially grade 5 or grade 4, sometimes we have relic. We call it relic joint. So this relic joint actually is the natural plane of weakness, so that it can when we understand, we have to find all these things. We understand that we can predetermine the failure plane in our analysis. So this is example, like this one, a very smooth plane, or we call it silicon side. And then this one also, this is all classic example from Hong Kong. And then the other part is flow accumulation zone. In tropical area, flow accumulation zone is very important. Okay, on top here, on top left here, this is image, IPSA image for Batangkali site before the failure occur. So, if you can see, there is stream. This is a surface stream actually running through this failure. So what happened when and then this, of course, the source is from top of this hill. So what happened when you construct embankment here, and then you have a very good embankment whereby the embankment become behave like a dam, no, stopping the water. Then after 30 years or maybe 25 years, the environment cannot longer hold the water. So that's one why it's failed. So this same thing here on the right here is in Ijuk, Perak. So the failure actually within the we call it flow accumulation zone, is a small catchment, a sub catchment. So you have a flow, but when they construct the road, they just they're not dumb. They do it proper embankment here. But unfortunately, they don't foresee this drainage pattern, so they don't allow any subsurface drainage to pass through the embankment. That's why when the thing give away, then the thing fail, and in Ijuk kill one person. So you get a house here, kill one person. It's similar like in Batangkali also is small scale earth flow. That's why the landslide can go quite far to the village area. Here also can go to about 550 meter away. So all these things is very important when we want to design or construct a slope, to understand the ground before we do our analysis. So this is a two geological geomorph features. It's been developed in Hong Kong. I'm sorry, I use a lot of Hong Kong paper because they publish a lot, and then they are quite similar situation with us. Only thing that they are subtropical, but we are more tropical. But it's okay. We can use a lot of their finding for our Malaysia. But of course, if we do a lot more research, we can have better understanding and better model of our ground in Malaysia. So on the left here is schematic hydrological process on slope by Hencher, Professor Hencher, 2000. So if we, let's say, if you go to the site and then you want to study or do forensic investigation after the failure, or in fact, if before the failure you want to do a study to understand the ground. So if we can find all these things that are written on this diagram, I think if we can understand or we can find 50% of what is written here, is very good enough. So that we can have a very good design and analysis on the slope. Whereby this on the right hand side here, this is for field slope. So always it's not only a cut slope, it's field slope also fail. So Dr. Sun, 1998, already put everything on this diagram, all the possible contributing factors to slope failure for field slope. So if you look into this, I think if you can find 50% of what is written in this diagram, I think we can solve a lot of problem. And remember, water is always the case. Water is the triggering factor in Malaysia. Of course, we have causal factor and we have triggering factor, and then water is always triggering factor. Either it's rain, whether it's rain or burst pipe, water pipe or leakage, surface drainage or whatever, is always water. And then when we do investigation for or what we to address in our slope stability analysis or investigation, this is paper. This table is from paper by Robin Fell, Hanger, Leroy, and Rimmer. This is a very good paper. In fact, Robin Fell, this paper is one of the paper presented in the UK Institute of Civil Engineer as part of a lecture. I suddenly forgot the name of the lecture. This very important lecture every year in the United Kingdom in geotechnical engineering. So if we ask all the question, I think we have no problem with our slope analysis or even landslide investigation. First, topography, geological setting, hydrology, and being a geotechnical engineer, you don't need to familiar with all these things. You just get, if those things you are not familiar, like geological setting, hydrology, get your friends, your partner, geologists to help you to understand the ground. So that is better than you try to understand by yourself, and then it's quite complicated later on. But if you do understand, that is the best. If you know all these things, then it's much better. Gender is role movement. So all these questions you need to answer. Then you can have a very good input. And then I just try to highlight here on the right diagram. This is a different stage of slope movement. This is published by Leroy in the lecture in United Kingdom also. I forgot the lecture name. The US we have Tazagi lecture. In UK you have another lecture. Suddenly I forgot. Sorry. Different stage. So we must understand when we study the landslide when occur, where are we actually? Whether it's post failure, or we already passed the post failure, is occasional reactivation, or we are at active landslide. So all these things is very important so that we understand and then we can mitigate the slope or landslide properly. So I move on into one of my case here is slope stability modeling analysis of rock. I'm more into rock slope because that my expertise. Because normally for soil, I think engineers is my better. Even though we help them also to understand the ground. So for this one, because we do from A to Z for road stability, is one road in KL. So this method now we establish within our group. We use TLS. I think you may be familiar with TLS, with ALS, with drone, thing like that. So those areas that we cannot reach by walk-over survey, we have to use drones to help us to survey. And then we have a PV data, joint set, rock material, and then we identify failure, and then only we do numerical. So in our team, we always have geologists start with the study, the site study, field investigation, things like that. And then in between, we will have engineers join the team for the numerical analysis as well as the later part mitigation design. So mitigation design is always the domain of the geotechnical engineers, and of course getting data input, geologists will help geotechnical engineer. So this is the methodology: data acquisition, joint set identification, potential failure mode, And then we go to numerical analysis. We have to decide also whether you want to use Hook Brown criteria or it's just a single uh, uh, controlled by a single joint. So we use button bendis failure criterion. Is it toppling, or even sometimes if the rock if behave like soil when the failure like in this case, if the soil can feel like sorry, the rock also can feel like a soil, a circular failure. So we need to do some analysis using more column method. I mean, criteria analysis, and then we can get a better. So that's why we have to know dealing with the weathered rock is between soil mechanic, rock mechanic. In between, we need to know when to use soil mechanic, when to use rock mechanic. So then only we can get a better outcome. This just a result. So because okay, this normally geologists familiar with this stereo net, and then we do analysis, then we know potential failure mode, failure plane, thing like that. And of course, when we do it the block, so that the non-technical people to understand, so we have to tell them why the failure is like that, what is the um, discontinuity or joints that embedded in the rock mass. So this is another. So we continue with the analysis so that we understand what is the mitigation measure that we require. For example, like this on the right bottom. So when we want to have a factor of safety of more than 1.5, so you cannot no longer can install 6-meter rowboat. We have to install 12-meter rowboat with 18 ton per meter per boat, so that it can increase the factor of safety to more than 1.5. So all these things you have to some a bit try and error, and then to understand the ground, so that like the waste here, we cannot, if you don't understand the failure plane and mode, then you may end up have a rock boat within the failure block. So by right, it should go beyond the failure block. So then now it's very easy. You have photogrammetry using drone, so you can visualize your slope and then put all the mitigation measure on the slope itself. All right, and then now I touch a bit on the use of aerial photogrammetry and terrestrial laser scanner for slope stability. This is not only for rock slope, but can be used also for soil slope, that you can develop a cross section immediately after you carry out the TLS. So you can have very good and a very accurate cross section for your analysis and for your design. And then in this case, we can capture if you sometimes if the slope is too big, when you go inside the slope, you cannot see a thing as in a bigger picture in the bird eye view. But with aerial photogrammetry with TLS, you can see a lot of things that you cannot see sometimes if you walk down the slope. So so then only we can have a better uh, proposal for mitigation. Okay, now I move on into slope mitigation measures. Design approach for slope stabilization, we have three approach normally. Geometrical method, which is you have to change the slope geometry in order to make the slope or more stable, like slope flattening, removal of part of the soil or rock or terracing or thing like that. Okay, and then hydrological method. This is to control the groundwater table, to and then to reduce for water pressure, so that the slope body can be stable. Like we install horizontal drain, and then sometimes most of the time, not sometimes, sorry, most of the time we put surface or subsurface drains to drain out water outside from the slope body. And then lastly, chemical or mechanical methods. This is to enhance or to increase the shear strength of the sliding soil rock mesh, or to increase or external force causing the slope failure to reduce. So the method is grouting, rock bolting, retaining structure, soil nailing, etc. And then for slope remedial method, there is a 5 method. So normally we start with mechanical method. We have like we're using geostatic. We introduce other material into the slope for construction of slope. So nail, sheet pile, soldier pile, or retaining structure. And then assault method. Assault method ni more like we control the geometry of the slope, rebuilding, compaction, benching, stepping, etc. And then bioengineering method also, we have live stacking, like we what you call it, install some vegetation or plant that's suitable to strengthen the slope. Live machine, when you introduce like fiber, coconut fiber, thing like that. And then brush layering, log terracing, but log terracing is not common in Malaysia. And then one I want to highlight is veggie grout. Veggie grout is developed by Unit 10, and it's very good now. It will be proven in Plus and JKR, where we install liquid that make from waste vegetable, so that it can strengthen the ground and then can make the ground more fertilized for plant to grow. And then now we talk about nature-based solution also. I think now everywhere, everybody now tries to talk about nature-based solution, using trees, maybe using whatever nature to mitigate or to make the slope, to strengthen the slope, thing like that. So this is another angle that we need to do more research on this. In fact, I just came back from Italy last week for debris flow conference. They know already what type of plant or trees suitable for certain area, because they already study up to that the name of the tree also or plant is suitable for what, and then how it behave, what is the strength of the roots, thing like that. Their research already up to that extent, so they're very advanced in terms of nature-based solution. And then next is additive, lime, cement. We use cement for concrete sprays or garnetting, thing like that. And then water management, of course, like mentioned earlier, hydrology, surface drainage, subsurface drainage. This is, I think, I will go quickly on this part because I believe you already, your lecturer already teach you about this. So retaining structure, and then another retaining structure, block masonry wall, gravity wall, like counterpart is seldom used in Malaysia. Cantilever wall, linear wall also I don't see many. And then we have sheet pile sometimes. Sometimes they use temporary, but in rural area, sometimes sheet pile with reinforcement with tie back can become a permanent solution to a rural area, because the loading is not so great. And then contiguous wall pile, if we drive from Simpang Pulai to Cameron Highland, you can see some wall is a contiguous wall pile, of course with tie back. And then if recent failure in Bukit Tungku, the apa nama anti-corruption building. So we can see some slope actually already been stable. I mean, it's not stabilized, strengthened by using contiguous micropile. But unfortunately, I cannot see any tieback. So that's why maybe the thing give way. And then we have a soil annealing. This is very common. You can see everywhere. Even though I'm personally don't like soil annealing. I'm not soil annealing. Sorry, I don't like the concrete spray because you can see all cement on the slope. I prefer greener slope, but this is some area, especially on the very high potential of erosion or erodible rock material or very fractured, highly fractured material, you need this some sort of concrete spray or garnetting to reduce. I mean to stop water from infiltrating into the slope body. Geosynthetic, we have geotextile, geonet, geocell, geogrid. All these I think common, but must be taught by your lecturer in any one of the subject, I believe. And then of course this is surface drainage. At least surface drainage is very powerful in terms of to what do you call it, to divert the to intercept the surface runoff to what do you call it, to make sure that the surface runoff don't go inside the slope body more than it is supposed to be. But unfortunately, most of the time, our surface drainage is poorly maintained. That when that the problem come in. You poorly maintain. You have a drain clog and then drain break lah, bocor lah, thing like that. So it's a lot of things. Then it's not working properly as per design. Then it become contributing factor to the failure of the slope. This is the case in Taman Permai Ampang recently. It's not properly maintained. And then surface drainage, subsurface drainage, horizontal drain, basically. You can see a lot of horizontal drain on the slope, the highway. Sometimes you cannot see what you call horizontal drain that water come out from the drain, but sometimes it is okay because it can help also reduce the pore pressure build up inside the slope body. So it's very useful method to reduce the pore pressure and then as well as subsurface water. This is subsurface drainage. So now I believe all the JKR design already include the subsurface drainage on their embankment slope. So this is a common practice now. And then there's a case study. I go very quickly on case study. Basically, rock slope mitigation measure. So for rock slope, we have two types of mitigation measures: stabilization measure and protection measure, to protect that or to want to stabilize the rock slope. Yeah. So this is again from the previous slide. We have two conditions here. This is a rock exposure, and then this is a soil or a weathered rock. So we have two different approach. So this is we use rock bowl to strengthen and stabilize the slope. It's all the calculation, and then and this is sample calculation from our engineers. So when you do using computer, at point of time, sometimes you need to do a manual calculation, sometimes to give comfort to yourself. Sometimes whether the computer do correct things to you for you or not, yeah, thing like like that. So this is a cross section design, and then we need to before we come up with the drawing, we need to make sure that all these things is workable through calculation, thing like that. And then the other part is a soil slope. So what we do is we propose stone pitching and rock fill. We do some infiltration, model analysis, water infiltration into the body, and then when is slope going to fade, thing like that. We run some praxis, numerical analysis, and then we come up with a design of combination of a rock fill. Here is a rock fill at the berm, and then we have a rock stone pitching in between, so that we can reduce the cost to repair this failure. So just to show another part that we do actually, this 1 hour discussion we want to talk about. Recently we have a debris flow in Jerai and Baling. We have the opportunity to run a model. This is a simulation program. It's not a stability analysis. It's just to identify how is the flow will behave if the thing happen. So we are opportunity we have calibrate with our field investigation, thing like that. And then this must like part of my lecture, some suggested material that I think easy to read and is good if you want to understand. Because of course I'm geological background, is more on geology and rock inside this reading material. But there is also one good book is on soil and mechanics. Soil and foundation here by Professor John Atkinson, and John Atkinson also have a fundamental of ground engineering. This is a very compressed geotechnical or ground engineering understanding with all the equation formula to be used on certain analysis. And then the other one is geological. This is also very good book. It covers soil, but more on rock. But it's a lot of explanation, a lot of case study, a lot of equation. Very practical, I think. This is a very good book. And then for journal, this is I believe for landslide especially some of the good journal. Of course, you have a geotechnic from Institute of Civil Engineer UK, and then you have geotechnical journal. This is from American Society of Civil Engineer. And then landslide is an international consortium of landslide, and then you have a lot of this for engineering geology and rock mechanic stuff. And then another one is the Canadian Geotechnical Journal. Is also very good journal for geotechnical engineers. I think that's all for my presentation today. Thank you very much. If you have a question, then we can discuss after this. Back to you, Dr. Ng.
Yeah, thank you, Tuan Abdul Rashid, for that insightful presentation. We appreciate your expertise and the effort you put into this presentation. Okay, now is the time for Q&A session. So if you have any question, you can ask. Okay, you can unmute and ask, or you can type in the chat box. Okay, students, ada soalan boleh tanya. You can ask in English or in Malay, no problem. Any questions?
Semua faham kot? Okay.
They are very shy.
Dia pun tak faham. I hope you can understand ni apa nama on this. Actually, I have another presentation yang I buat dekat universiti selalu I pergi, tapi mainly on undergraduate level, I call it engineering geology for civil engineers. So I can explain a bit on understanding of engineering geology, thing like that lah.
So let me ask one question. So this is more to education. So do you think the engineering geology or this rock mechanics should be taught in this civil engineering undergraduate student? You rasa perlu ke? Kerana apa yang kita belajar sekarang adalah geologi secara umum dan juga soil mekanik. Tapi kita tak ajar rock mechanic dan kita ajar engineering geology secara detail. So basically graduate kita sebenarnya tak begitu tahu macam mana design untuk rocks punya slope.
So I think tak banyak, tak semua. I think majority civil engineering class memang kurang ajar geotechnical, rock mechanic, because you don't have time actually. So but for me, I suggest, because kalau you ajar normal geology, kalau normal geology lecturer dia akan ajar pasal geologi yang I don't know, may not relevant to civil engineering, so that the student will get bored, and then jadi dia tak fokus on why geology is important. But if you have a lecturer yang combine, katakan dia ajar engineering geology and a bit of soil, a bit of rock mechanic, then you attract student more, I think, because you use how to use geology in civil engineering purpose or in geotechnical engineering purpose. So it's very important. Kalau normal geology, kadang-kadang geologist dia ajar pasal mineral, pasal age ke, pasal paleontology. I mean a lot of geologists, kalau dia ajar yang not relevant, because actually all those things is relevant, important, but only certain thing that engineers should know. It's not everything. Kalau everything, then dia akan jadi boring, and then jadi give up to follow. Even my son now is a third year civil engineering student. Dia pun cakap boring belajar geologi pasal banyak baca lah, banyak ni lah, banyak apa kan. So this how I think you need to be creative lah on this.
Alright. Okay. Any questions from the floor?
Saya nak tanya. So macam bila kita dealing dengan rock slope ni kan, so sudah tentu dia punya failure mode ni different kan dari dengan soil slope kan, betul?
Betul.
So dia mungkin dia punya any set discontinuity tu maybe free, sama ada dia fall ataupun dia slide, betul? So adakah dia appropriate kalau kita nak determine failure tu using more column?
Okay, tadi yang saya explain. Kadang-kadang rock ni, dia kalau highly, ada satu case dekat KL kita buat, very highly fractured rock. So dia tak ada pattern, tak ada pattern dari segi discontinuity. Dia punya joint tu tak ada pattern. So bila dia fail, dia boleh fail the whole slope, boleh fail. So dia akan behave like a more column material. So then only you boleh gunakan more column punya approach lah untuk. Tapi kalau you nampak dia you boleh nampak dia punya block tu satu block, and then you boleh nampak dia punya join apa semua, and then it may be controlled by joint, and then you have to use rock mechanic punya approach lah, hook ground, failure mode ke, ataupun bottom bandis yang saya cakap tadi lah.
Okay. Ada soalan lain?
I hope you all dapatlah apa yang saya sampaikan, faham . Dia tak tanya tak apa, tapi saya harap you faham and then you understand.
Faham, Ustaz.
Okay.
Saya rasa mereka faham lah. Ada banyak persoalan masih ada
Rashid,
faham lah. Ya,
Zarin lah, ya.
okay.
Bang, okay, actually, from my experience lah, kita, I'm a geologist actually, Rashid. Always
Okay.
hear your talk lah. Kita
Okay.
dalam satu board kan. Cuma sekarang ni for engineering part lah, mostly kadang-kadang kita memang macam cakap lah, bila saya bicara dalam dunia pekerjaan kan, when geologist meet dengan engineer, always have some clash lah. Sebab engineer dia akan more linear tu dia punya term and theories. Dan kita geologist ni, kita banyak, orang kata banyak imajinasi kita tu nak mewujudkan benda yang kita tak nampak. So basically, ada tak Encik Rashid, saya pun macam ingat lupa benda ni. Mostly on the definition of the grade lah. For us, kita nampak kita ada 6 grade, where grade 1 tu memang fresh rock, or kita panggil fresh rock, and grade 6 tu memang apa, kita
Residual soil.
residual soil punya part lah. Macam kita akan panggil soft rock. So the thing, ada tak satu apa orang cakap, on the slope punya part, dia boleh tak dia menggradekan benda tu based on the slope body yang move downwards tu?
Slope body yang move downward.
Macam anda kata macam landslide kan, dia ada tak satu standard kata okay, landslide benda ni turun sampai soil, sampai grade berapa ke?
Oh, okay. Kalau failure dia berlaku selalu senang Failure berlaku in between grade 6 and grade 5. That's one failure, shallow failure. The soil failure. Satu lagi dia akan deep seated failure, dia akan berlaku antara grade 4 dengan grade 3. Ini common lah, deep seated failure antara soil dengan rock pula. Satu antara residual soil dengan saprolite, dengan soil yang ada feature rock. Satu lagi antara saprolite dengan tu. Okay, that's one part. Dan bila kita investigate slope katakan, dalam British Standard dia ada satu flow chart yang dikatakan whenever we cannot classify as a grade, as a grading maknanya kita tak boleh identify dia as a grade 1 sampai grade 6 tu clearly. And then most of the time our slope memang macam tu. We cannot identify really. Kalau tak, dia akan jadi kelakar, dia akan jadi you 6 sana, 5 sini, you akan jadi banyak. So what is proposed is you bukan buat grading macam tu. You buat classification dia based on portion of rock and soil. So that itu yang ada tadi PW tu, parent rock dengan weathered rock, PW sama ada 50%, 30%. So that when you group like this, then you akan categorize dia sama ada dia behave as a rock or dia akan behave as soil. And then kalau dia collovium pula, ada satu part lagi, you behave as a collovium. Collovium ni kalau dalam rock making dia panggil block in mass rock, beam rock dia panggil beam rock, block and mass rock. So dia ada kriteria dia sendiri. So bila kita buat analisis, so when you analyze the mass, so dia akan behave as a mass punya tu, as a rock ataupun as a soil ataupun as a beam rock. So benda-benda ni yang kita kenal tu, this is very fundamental lah in term of kita identify before kita tahu landslide tu nak berlaku kat mana ke apa kan. Once kita identify benda-benda ni, then kita akan dapat rasa lah benda tu, apa nama, landslide tu sebenarnya kat mana dia punya plane apa semua tu. Agak menjawab lah Zarin
Menjawab, betul. Saya nak confirmkan benda tu lah, sebab saya ada keliru sikit lah. Kita baru berjinak-jinak dekat landslide ni.
Okay.
Any more questions? Okay. We can take one more questions.
Bukan senang nak datang Penang ni, Dr. Ng, jauh ni.
Ah.
Tanyalah.
Jauh Penang tu.
Next time boleh jemput Cik Rashid datang UiTM Penang. Ah.
Oh, boleh. InsyaAllah.
Okay, I think if there's no questions, so we have come to the end of this online technical talks. I would like to express my sincere gratitude to Rashid Jafar for enlightening us with his knowledge and expertise on this landslide issue. Okay, thank you all for joining us today. We hope you found this talk insightful and valuable. So before you left, let's take the photo together. Okay, kalau boleh turn on your camera. So kita boleh ambil gambar sama-sama. Okay. Okay, please turn on. Ramai sikit. Sekarang 5 orang je. Okay, yang turn on ni. Ramai lagi yang tak turn on ni. 33 lagi. Ha. Malu kan?
Dah malam lah, Doktor.
Malam lah. Tak mau show muka dia.
Semua dah pakai baju tidur lah.
Okay, okay. Foto I masuk dah. Okay, smile. Okay, 1, 2, 3. 10. Okay. Thank you. Terima kasih. Okay, sebelum balik, kita kena fill up this attendance forms. Attendance form. Nanti saya share dalam sekarang. Okay, saya share attendance form dalam chat box. Semua kena isi. Ya, dengan balik dulu, isi attendance form. You akan dapat CG. You get this certification cert.
Mana chatbot dia?
Chatbot. Okay, saya dah share. So please fill up this form. Okay, you akan dapat cert. You kena check you punya email untuk dapatkan cert ni. So pastikan you masukkan email yang betul lah. Okay. So once again, I want to thank the speakers and everyone for participation. Thank you all and have a great day. Terima kasih semua.
Thank you, Dr. Thank you semua. Assalamualaikum.
Thank you.
Thank you.